Hi, my name is Paul van Donkelaar, and I'm a professor in the School of Health and Exercise Sciences at the University of British Columbia Okanagan campus. And today I'm going to be speaking in series number 1, asking the question, what are we doing to research concussion in kids? I'm going to be looking at some of the research that we've been doing investigating the executive dysfunction following concussion in adolescents and addressing the more specific question of what measures can be used to objectively and sensitively test executive dysfunction following concussion in adolescents. But first, just a little bit about who I am. I completed my PhD in clinical neurosciences from the University of Calgary in 1994. I then did 1 year as an NSERC postdoctoral awardee at the Université de Provence in Marseille, France, followed by another 2 years as a postdoctoral fellow at the University of Oxford in England. I then started my first faculty position in the Department of Human Physiology at the University of Oregon, where I spent 14 years. And then just over 4 years ago, I moved to the School of Health and Exercise Sciences at the UBC Okanagan campus in Kelowna, British Columbia. The research that my group does is aimed at gaining a better understanding of the neurocognitive, sensory-motor, and cerebrovascular effects of acute concussion. And the goal really is to generate knowledge that will allow us to create more objective assessments of concussion to aid with the diagnosis and management of this injury. To do this, we use state-of-the-art behavioral and physiological measures, and we compare recently concussed individuals to matched controls. More recently, we've started to examine the chronic effects of subconcussive blows in the context of contact sports. So in other words, what happens if you get hit repeatedly over the course of a game or a season, but never actually get diagnosed with a concussion. So what I thought I would do is give you a little bit of a tour, an example of some of the research that we've undertaken in the context of concussion. The first thing I want to talk about is some of the neurocognitive deficits that occur in concussion. And for this purpose, we've developed and used a task that probes executive function. And this task is called a task switching task. And at its essence, what it requires participants to do is follow rules regarding the mapping of different stimuli onto different responses, and then switch that mapping in a systematic way by following a specific set of instructions that was provided before they start every trial. And so what I have on the left-hand side of the graph here is an example of a sequence of trials that occur in which a target stimulus is presented to the subject and a specific response is required. And so if we start on the leftmost side of the figure, you'll see that there's a black square that appears in the top part of the visual display screen that the subject is facing. And under this particular set of constraints, the subject is meant to respond in a congruent manner. So, in other words, when the target appears in the upper part of the screen, they're meant to press the upper response key. In the subsequent trial, the target in this example appears in the upper part of the screen again, and they're meant to follow the same rule. And so they respond congruently again by pressing the upper response button. Then a switch occurs. So now, instead of responding congruently, the subject is meant to respond incongruently. So in this example, the target appears on the lower part of the screen, and an accurate and appropriate incongruent response, therefore, is to press the upper button. On the subsequent trial, the rule is to stay again, that is, to respond incongruently, and so when the target appears in the upper part of the screen in this example, they press the lower button. They're then required to switch back, such that now instead of responding incongruently, they're meant to respond congruently again. So in this example, the target appears in the upper part of the screen, and they are meant to respond by pressing the upper button. And this will continue on for about 80 trials, and so the subject is meant to switch back and forth between responding congruently and incongruently, and then the reaction times and the accuracy of the button presses are recorded. And generally what you find, even in healthy individuals, is that there's a significant increase in reaction time on the switch trials compared to the stay trials, the trials where the subjects don't have to switch from responding in one way compared to another way. And so on the right-hand graph, what you'll see are those reaction time differences between switch trials and stay trials for two groups of subjects. In the white circles are the control subjects, and in the black squares are concussed individuals. And in this case, they're individuals from junior high school football teams, so in in the adolescent age range. And so if we focus first on the control individuals, you'll see that on the first testing day, that reaction time difference is about 120 milliseconds. So what that means is on trials where they're meant to switch from responding congruently to incongruently, or from responding incongruently to congruently, you get about a 120 millisecond increase in reaction time on those switch trials. When we tested them a week later, those switch costs or switch reaction time differences dropped down to just under 100 milliseconds. And then over the course of the month to 2 months after that initial testing period, they dropped down to about 60 milliseconds and then plateaued. So this indicates that over the course of repeated attempts to perform this task, healthy individuals actually get a little bit better at performing the task. So there's some practice effects or learning effects. In the concussed individuals, we tested them initially within 3 days of their injury. And on that first testing day, you can see that there's a substantial increase in that reaction time difference. So it's almost 200 milliseconds now instead of the 120 milliseconds that you see in the control individuals. So a very significant increase in that switch cost. And that increase is maintained within the first week, second week, first month, and even, although it's much smaller, over 2 months after the injury. And so it seems that task switching, this probe of executive function, is a very sensitive measure to the impact of a concussion. Now, the interesting thing is that the return to play decision was made within the first week, or within about 7 to 10 days after the injury in the concussed individuals. So their return to play quite quickly after their injury. So that gives you a sense of some of the research going on in my group assessing the effects of concussion. In terms of what is working, I think it's clear that there's some world-class research going on around concussion in Canada using state-of-the-art tools, and that's true at UBC. I've got active collaborations with a number of colleagues at the Vancouver campus of UBC and at other centers, so we're well positioned to be able to look at a number of different issues related to concussion. And within BC itself, there's an excellent clinical community knowledge translation aspect being carried out by the BC Concussion Advisory Network under the direction of Dr. Shalina Babul. In terms of what's not working or what's a challenge, I think certainly the recruitment of youth athletes in the Okanagan is sometimes a barrier in my current context. I think it's a little bit better in the Lower Mainland at some other centers. And then also within BC itself, there seems to be some challenges around coordinated efforts across different concussion researchers, and that seems to be something that works a lot better in some of the other provinces. In answer to the question, what I'm hoping to get out of the symposium, I think definitely the number one thing will be increased insight into the effects of concussion in youth athletes. I think certainly the symposium is going to be an opportunity to see some of the latest research efforts as well as clinical and education efforts around this topic. And then obviously it's also going to be a great opportunity to network and collaborate with other researchers, clinicians, educators in this area. So I'm really looking forward to the symposium.